HTTP is the application layer protocol of websites, as you will probably know. So this is why you see HTTP, go on / and then you go www.google.com, and that will take us to the HTTP version of the website. Now, if you look here, it literally sends text that looks like this to and from the servers. And this is the HTTP protocol here. It's saying that it's a HTTP protocol. It's talking about dates, servers, and then below it, you have the HTML code, which is what you will see if you look at the source code of the pages. It looks like this. So the HTTP is in plain text. Now, if I close this and actually go to Google and change it to HTTPS, I am now running HTTP over TLS or SSL. HTTPS provides the security services of TLS because it uses TLS, so data encryption, authentication, usually at the server side, message integrity, and optional client or browser authentication. When you access a website with HTTPS, the web server will start the task to invoke SSL and protect the communication. The server sends a message back to the client indicating a secure session should be established, and the client in response sends its security parameters. So that means it'll say, I'm prepared to use this digital signature, I'm prepared to use this key exchange algorithm, I'm prepared to use this symmetric key, and the server compares those security parameters to its own until it finds a match, and this is called the handshaking phase. The server authenticates the client by sending it a digital certificate, which we will be covering next. And if the client decides to trust the server, the process continues. The server can require the client to send over a digital certificate too for mutual authentication, but that doesn't often happen. But if you're looking for a full, secure, end-to-end session with authentication of yourself and the other side, you would use certificates at either side with digital signatures, those digital certificates providing the authentication. And you'll understand that a little bit more when we go through digital certificates. The client generates a symmetric session key, like by using AES, and encrypts it with the server's public key. This encrypted key is sent to the web server, and they both use this symmetric key to encrypt the data they send back and forth. This is how the secure channel is established. TLS requires a TLS-enabled server and browser, and all modern browsers support TLS, as we saw on the Wikipedia page. And in all of the browsers, you'll see HTTPS, which will indicate that TLS is being used, and you often see a padlock as well. And all of the browsers have some sort of equivalent of this in order for you to know that HTTPS or HTTP with TLS is being used. If this is not shown, then the connection is not encrypted or authenticated, and it'll be sent in plain text. So just as you see here, and all of the contents of the website, just as I can see them now, if HTTPS is not used. If we look at the padlock here, we can see the technical details for what the encryption algorithms are. So in this case, it's using TLS, it's using elliptical curve with Diffie-Hellman with the option of RSA. The symmetric key is AES with 128 bits with a GCM mode of operation and SHA-256 for data integrity. This will have been negotiated between the client and the server. And if we look in Wireshark, Wireshark is a protocol analyzer, so you can see the traffic as it goes in and out. I can see here the conversation that has happened where my client or my browser has said, these are the things that I support, and the server has responded and said, well, this is what I would actually like to use. And then they've provided the certificate with the digital signature and the public key on it. Another website you can go to is SSL Labs. And if you enter in the website or URL of a site that's running HTTPS, you can see what encryption options are offered by that site. So here we can see that Bank of America signature algorithm is SHA-256 with RSA. So that's for the digital signature. We can see the chain of trust here. That's Bank of America's certificate. The chain of trust comes down here. And then we have the root certificate here. And the protocols that the server is prepared to use. Quite an interesting site, and it gives you a rating for how good it thinks the site is. A final point on HTTPS and a privacy problem. Something called the Server Name Indication, SNI, is an extension to TLS by which a client indicates which hostname it is attempting to connect to at the start of the handshake process. And you can see that represented here within Wireshark. We can see the server name www.outlook.com. This allows a server to present multiple certificates on the same IP address and TCP port number, and hence allow multiple secure HTTPS websites or any other service over TLS to be secured by the same IP address without requiring all those sites to use the same certificate. The desired host name, as you can see here, is not encrypted, so an eavesdropper can see which site is being requested. SNI is used to implement censorship and block sites. SNI means if you're using HTTPS, eavesdroppers can see what site you are going to. But then after that, the communication is scrambled or encrypted.